Hello everyone, my name is Samudra Matak. Our project is design and development of a lower limb exoskeleton for walking assistance. Our department is mechanical engineering, 8th semester, group number 7. Our project guide is Sir Harajit, and our group members are Jyoti Nath, me, Hopsonbou, H.Mawithsang, and Basumatary. These are the contents. Lower limb exoskeletons can be divided into three broad categories based on their functionalities. The first category is human performance augmentation exoskeleton for increasing strength, endurance, and other physical capabilities for able-bodied individuals. The second broad category encompasses assistive devices for differently abled individuals. The third broad category is therapeutic exoskeleton for rehabilitation. This project is mainly focused on the third broad category of exoskeleton for providing walking assistance among patients who are recovering and rehabilitating from their injury. And these are some of the papers. There are more on the thesis. The first paper has presented a method for selecting appropriate size electric actuators and gearing to power the sagittal plane joints of a human exoskeleton. These are some of the more papers. The 8 number paper reviews the power lower limb exoskeleton, that is Mind Walker. The project of this proposed design is to provide active gait assistance in the sagittal plane while active control in the frontal plane is still missing. And these are the market survey. So our project is cost effective compared to the exoskeletons in the market. So it will be easily affordable by middle class people. It is also helpful for people having breathing problems, those who get tired in walking. It is also good for these exoskeletons for market in military. It is also helpful to rehabilitate injured patients. It is very good for old age people, and it is also helpful for heart disease peoples. And this is the objectives. It will be explained by Hopsonbou.
Hello everyone, my name is Hopsonbou and my topic for presentation is objective of our project and working mechanisms of our model. Objective. Our objective is to study the various categories, types of exoskeleton currently available in the market to meet the needs of proper working mechanisms suitable for the exoskeletons. Our objective is also to design a proper working mechanism suitable for the exoskeleton. Our objective is also to develop a working lower limb exoskeleton capable of assisting a patient to walk or move about who is suffering or recovering from a particular lower limb injury. Mechanisms and working of our model. Our model consists of 3 primary links and 2 auxiliary links. As we can see in the figure, the primary link 1 is fixed in the waist with the help of belts and straps, and thus this link will be fixed. The second primary link is connected to the fixed link through a hinge joint, and thus allowed to swing back and forth. The third link is connected to link 2 as of link 2 is connected to link 1, that is the fixed link. The auxiliary link 1 and 2, as we can see in the figure, is connected to the primary link 2 and 3 respectively, thus forming a 4-bar linkage. As we can see in the figure, the linear actuator is placed on the fixed link facing downward. The pistons of the actuator and the joint of the 2 auxiliary links are connected through a connecting rod. So at the initial position, the actuator will be at the maximum strokes, and as the stroke is decreased, the piston will pull the connecting rod up and upward and lifting the link 2 and 3. The link 2 will be strapped on the tight part of the user, and link 3 on the lower part of the legs, on the lower part of his leg, his hard leg. Therefore, the mechanism will have to lift the legs up and down, and the forward steps will also be obtained during the lift down. The next slide will be presented by Harajit. Thank you.
Hello everyone, myself Harajit Basumatary. From here I'm going to do the presentation. For components, what we have used? We have used the actuator up to 2 and a linear actuator frame up to 2 and aluminium of 6063T5 and a controller 1 8 to 35 volt DC controller. Next, what is the material specification? Material specification of the Voltric stripe of the 4-meter thin plastic stripe and a lithium-ion power bank, one 6000 megawatt battery, and the foot pad, 2 plastic pad with a stripe, and a mounting bracket, 4 aluminum clamps, and a connecting rod, 2 aluminum pipes, and a connecting link, 4 and aluminum sheet, nut and bolt 12, and screw 14, waist belt with a pocket, 1 nylon belt, and a connecting wire as required polycap wires and proposed design. This is our proposed design which we have finalized. The first one is the front view and the second is the back view and isometric view, and the fourth and fifth the top view and the bottom view which we have designed. This is the animation of the mechanism. The next slide will be further explained by Jyoti Nath. Thank you so much.
Hello everyone, I am Jyoti Nath and I am going to explain about components part. The first component is frame. The frame is rectangular parts whose structure is made of aluminum. Parts are joined by together to get the structure which is chassis of the whole exoskeleton. Holes and mountings have been done in the frame to hold the actuator and the links. Then next part is actuator. The actuator is the component which is responsible for the moving and controlling of our mechanism. It's mainly required to controller and a power source for its working. We have used 2 linear electric actuator motor for our project. Then we have controller. The actuator controller is a wireless remote control for linear actuator electric motor. It is forward reversed controller which enables the linear actuator moving forward and backward. The remote controls comes along with a forward reverse controller that enables distance controlling. A control forward turn in one leg and a reverse turn in another. Then we have velcro strips. It is a fastener for clothes or other items, consisting of 2 strips of thin plastic sheet, one covered with tiny loops and the other with tiny flexible hooks, which are there when pressed together and can be separated when pulled apart deliberately. It will be fitted with rings attached in the frame to hold the exoskeleton with the body parts. Then we have lithium ion battery bank. A lithium ion battery bank is a type of rechargeable battery. Lithium ion batteries are commonly used for portable electronics and electric vehicles and are growing in popularity for military and aerospace application. We will use 600 mAh battery which will power exoskeleton to work around 2 hours. Then we have footpad. It is the part of the exoskeleton which is attached to the frame with screw and clamps. It helps to adjust the height and size of the person to fit the exoskeleton. Then we have mounting brackets bolt. It is just like clamps which are used to on both sides of an actuator. It is helps the actuator to fit with the frame perfectly. Then we have connecting rod. It is aluminum rod or pipe attached to the actuator on the rod one side to end connecting links on the other side. It's help to give movement to the legs on the required direction. Then we have connecting links. It is plate that is used to connect two parts of the frame which with screw to give a free movement between two parts. Then we have Nath and bolt. A Nath and bolt type of fastener with threaded hole. The nuts are almost always used in conjunction with a mating bolt to fasten multiple parts together. The two partners are kept together by combining of their threads friction, a slight straightening of the bolt, and compression of the part to be held together. The bolt is a form of a thread fastener with an external male thread. Bolts are closely related to screw. Then we have screws. A screw is type of a fastener in some ways similar to a bolt, typically made of metal and characterized by a helical rigid known a male thread which is external thread. Screws are used to fasten materials by digging in and wedging into a material when turned, while the thread cuts grooves in the fastener material that may help pull fastened materials together to prevent pull out. Then we have waist belt with it is a belt with which will contain the power bank and the battery, and will be attached with the frame from both sides of the leg to give support to the frame. Then we have connecting wires. It will be used to connect the actuator and the controller to the power source. And the next part will be discussed by Harajit Basumatary. Thank you.
Hello everyone, my name is H.Mawithsang. I'll be explaining the part similar data analysis. So we have gone through a lot of different papers, and these data represented on this page are similar data that we got from the papers that we have studied and are also similar to our project's data. The graph given below in this slide is a careful analysis of the power dissipation in the exoskeleton. We found out that the ankle requires 93 watt of electrical power to produce 13.5 watt of mechanical output during walking. As for the knee, 81 watt of electrical power is required for level walking, even though the joints needs to absorb 17 watt of mechanical power. Next slide, we have the knee. And the graph given here is the power consumption at the knee during level walking. From all these above data, we found out that our exoskeleton would weigh around 15 kg and would require 6000 mAh milliampere per hour battery to run for around 2 hours. Next slide, we have the advantages. Here, firstly, we have it prevents muscle atrophy and can also enhance recovery in case of damage. Next, autonomy of user by allowing them to do things independently. Also, it improves the psychological state of the user. It also makes the user adapt to all environments for normal daily motion such as walking and stair climbing. And it reduces the energy required to move the knee. That the primary joints, the knee, hip, or ankle. Lastly, it targets specific joints for rehabilitation purposes. Our project also have some drawbacks or disadvantages which can be fixed. Our model is quite heavy, which makes it less convenient for use, and also it is not made fully automatic. Next slide is our project schedule. This is the schedule of phase 1, which was done back in our 7th semester. The information is given based on monthly progress. Step phase 2. As we all know, with the outbreak of the novel COVID-19 virus, the progress of our project was immensely halted and disturbed. As a result, we could not complete the fabrication of our working model. But to compensate, we tried our best to complete the project work with the proper CAD models and analysis. We started our thesis preparation during the month of March and finished it by April. Futurescope. These are the Futurescope that we hope to improve on. Use of lesser amount of materials to decrease weight. Use of fully automatic controller. Use of location tracker for finding locations. Use of gyroscope for easy balance. Use of high power batteries for longer use. Use of high speed actuators. Finally, to conclusion, exoskeleton technology, although proven to be beneficial and advantageous in the area of rehabilitation of patients, still has its own challenges that needs to be addressed. With this project, we have come up with the idea of implementing a 4-bar linkage or mechanism powered by an electric linear actuator to tackle and help patients with various lower limb injuries to assist them in their rehabilitation. So these are the references. I would also like to point out that this project is funded by ASTC. Thank you.